we're going to start with this. And I think that best thing to do is the ratio test. So I'm going to take the limit as n approaches infinity. We have n plus 1 over n. So we have 3x minus 2, n plus 1 over n plus 1 times 3 to the n plus 1 all over 3x minus 2 to the n over n times 3 to the n. To make it easier, I'm going to write it out to make this make more sense. So we have 3x minus 2 to the n plus 1 over n plus 1 to 3 n plus 1 times, flip this, we have n times 3 to the n over 3x minus 2 to the n. We can break this down. 3x minus 2 to the n times 3x minus 2. We can also break the 3 down to 3 times n, 3 to the n times 3. So when we do that, we have stuff cancel. 3 to the n cancels. 3x minus 2 to the n cancels. So we end up with n times 3x minus 2 all over 3 times n plus 1. So we can ignore this since this is an x, that's just going to be some number. But if we look at this, we have n and 3 to the n. We can compare those. So that equals 1/3. Well, that's less than 1, so it converges. But we have this part here. So it's really minus 2. We're going to set that less than equal to 1. If it converges, it has to be less than 1. So 3x minus 2 can equal 1, or it can equal negative 1, since it's under the absolute value bars. So here we have that equals 3, 3x equals 3, equals 1. So then when we do this, we have plus 2. So we get 2 minus 1 equals 1 divided by 3. So equals 1/3. So now we have 1/3 and 1. Now we need to check those. By plugging in these two numbers. So we plug those in to here. We have 1/3 times 3 is 1. So we have 1 minus 2, which is negative 1 to the n. Into 3n. Just 3 minus 2 is... No, that's a positive 1. No, it's not. Negative 1. We also have 3 times 1 is 3 minus 2 is 1. 1 to the n over 3 and to the 3n. So when we check these, we don't take the limit, but we're checking to see if they converge. So let's say we take the alternating series for this. For this one, 1 to the n will always be 1, so we just have 1 over n to the 3n. Well, we can check that by b sub n to the 3n. That's what b sub n will be, 1 over that. Well, when we take the limit, this approaches infinity. So this whole thing approaches 0. And we have to check if it decreases. So we have 1 over n to 3n. We have 1 over plus 1 to 3n plus 1. Well, this is, bottom is larger than this one because you're adding 1. But that makes this smaller than this one. So this one is bigger. So that is satisfied, means it's decreasing. And since n equals 0, the other part is satisfied. So now we go on to this one. Like I said, 1 to the n will always be 1. So we have the sum of 1 over n to the 3n. I'd say the easiest would be the ratio test again. I'm just going to write it out the easy way. So we have 1 over n plus 1 to 3n. We also have n to the 3n over 1. Take the reciprocal. We can do this n plus 1, 3 to the n plus 1. We can do the same thing here, 3 to the n times 3. Well, that cancels the 3's. So we have the limit as n approaches infinity of n over 3 times n plus 1. Similar kind of thing here. Look at this. We have 1n over 3n, which is 1/3, just less than 1. So this converges also. So both of these converge. So really we're going to have 1/3, 1. I'm going to change it to that since they both converge. Now we need the radius of convergence. Now when we look at this, we can look at number line. Well, if we look up here, we have 3x minus 2, so x is at 3x equals 2. X equals 2/3. One sitting here, 1/3 sitting here. So these are close. We can look at it. This we have 1/3 here, 1/3 here. 1/3 plus 2/3 equals 1. 1/3 plus 1/3 equals 2/3. So radius equals 1/3, and it's centered at 2/3. And that's it.